All right, I think we're started. Sorry, give me a sec. All right, so this is called Intermediate Value Theorem. We abbreviate it as IVT, which makes sense, right? Intermediate Value Theorem. So it's going to talk something about intermediate, right? In between. Kind of makes sense, right? So that's what the definition is going to deal with. It's going to deal with function values that are in between another function value, right? So we're looking at your x's and your y's, and there's something in between or intermediaries in there. This is the intermediate value theorem, word for word. This is what you got to work on for Monday's quiz, having this memorized word for word, okay? So it's if f is continuous on the closed interval from a to b, and k is any number between f of a and f of b, then there is at least one number, c, in a, b, such that f of c equals k. You got it? Yes. Easy, right? No problem. All right. It's going to make it easier as we go through and do the problem. So similarly to the continuity quiz, you'll have to know the definition word for word, and then you will have to do a problem with it. I think Monday's quiz only has one problem. It doesn't have two like continuity did. I think there's just one on Monday, so it's a little shorter. Okay. As you do the problems, though, the definition will make more sense, and then it'll make it easier to memorize. Okay, so let's go through, and I'm just going to draw a picture because I think you need to visually see what's happening here and where this is coming from and what in the world they're talking about. So we have some function f that's continuous on the closed interval from a to b. So I'm going to just do first quadrant here, and I'm going to say these are x values, okay? These a and b's here, okay? Those are x values. So from some a to some b, they don't have to be x values. I mean, they don't have to be positive always, but they are x values. We've got some function that is continuous. So in that interval, my function is continuous. So whatever, I know I've got some graph, right? And it's continuous throughout that whole interval. Meaning there's no holes, there's no jumps, there's no breaks. It's just a nice continuous function in that area, okay? K is any number between f of a and f of b. So k is a y value because f of a and f of b are y values, right? So let's first find f of a and f of b. Well, if this is a, then this is f of a, right? That's the y value that corresponds to that x value, a. And where would f of b be? Somewhere over here. Okay. So what our intermediate value theorem says is that there is some k between f of a and f of b. So there has to be a k, any number between f of a and f of b. So between f of a and f of b, there is some k. Now what that says is I can go backwards now. Then it means that there has to be an x value that's going to correspond to that y value of k. There has to be some x value, and we call it c. So that's this next part. There is at least one number c in a and b, right? So this is an x value because it's in between a and b. So c has to fall in a and b in order for this this whole situation to happen, right? Such that f of c equals k. Does that make sense? Right? F of c has to equal k in this case, right, for that to work. So that's where you get that intermediate value theorem. The in-between value theorem is there. It's in between the two values. C is in between a and b, and k is in between f of a and f of b, okay? Now, the one thing I want to make clear is this idea of at least one number. Well, in this case, you're like, well, it has to just be one number, c. So what's up with that word at least? Why does that make a difference? So the situation where it could be more than one would be something more like this, right? Where I've got something, I don't know, where let's say this is my a, so this would be f of a, right? And then like, I don't know, let's say maybe this was b here. So this is f of b way up here. Okay. So then if I were to pick some k in here, notice I have one c, but I also have another c and another c. All of these c's give me an f of c equal to k because of the repeating function value there, just because of that. So that's why they say at least one value c. The majority of the examples you guys are going to see are going to be this one with just the one c for every k. But if it has a function like this, right, where you might see some repeaters in there, then you could have more than one c for that y value of k. Okay? Some hints in terms of memorizing this whole thing. Break it down into different sections for yourself, okay? If f is continuous on the closed interval from a to b, and k is any number between f of a and f of b, then there is at least one number c in AB such that f of c equals k. Do like smaller chunks, okay, to help yourself memorize this better, because there is a lot going on there. It's like it's one sentence. I can memorize one sentence. There's a lot of letters, there's a lot of numbers, a lot of weird stuff in there. Well, not numbers, but you get what I'm saying. All right, so let's apply it to an example, because I think this doesn't really make sense unless we see some examples. So example 3, I don't know why it's 3 and not 1, but we're going to go with example 3. And there is a little typo on this, so I'm going to fix that first. So we have this function, x to the third and x cubic minus 5x squared plus 7x minus 9. Use the intermediate value theorem to prove that there is a real number a, and they should have said right here, it should have said a in the interval from 6 to 7. Sorry, that should have been in there. So they should give you the interval, and that's the x value interval. They should give you that interval in the problem, okay? So we're trying to prove that there is some a in 6 to 7 such that f of a equals c. What have they done here? They've switched the c from before into an a this time. Okay, so again, they're playing, like it's hard because they are going to switch variables. They don't have to use c. And so you just kind of got to go with it, right? So let's kind of think, what are we trying to prove here, right? So I'm going to go with a quick graph because I think that's going to make a little bit more sense. And we're looking something in the interval from 6 to 7, right? Now I don't have to know what this graph looks like. I couldn't graph this by hand. I don't know how to graph this cubic. It's kind of long and big. I don't know how to graph it by hand. I know it's going to squiggle somewhere, right? But I don't really know where, okay? But what I do know is I can plug in a 6 to get my y value. I can get my f of 6, and I can plug in a 7, and I can get my y value there. So let's start with that. Let's plug in a 6 into this. So I get 6 to the third minus 5 times 6 squared. And then let's also do f of 7. So go ahead. If you want to use your calculators, you can. If you can do this by hand, awesome. No, but this one's a little harder. Okay, so your first step is going to be to find f of 6 and f of 7. So once you get it, tell me what you guys get. 69 for the first one? Okay. How about for f of 7? What'd you get? Anybody? F of 7? Not yet? Calculate. 7 to the third minus 5 times 7 squared plus 7. Come on, people. You got calculators. You're faster than I am. 138. Thank you. Anybody confirming these? Are we just trusting? We're good? 138? Okay. All right, so I'm going to do a little, like, just a visual here. So f of 6 is 69. Here we go. So it's some point here. And f of 7 is 138. Okay? So that's here. Because intermediate value theorem, the first part of it is really important, you guys. It said it is continuous on this closed interval that we're dealing with. So is this continuous on the closed interval from 6 to 7? Well, yeah, it's a cubic, right? And a cubic graph is going to be continuous throughout the whole thing, okay? So the first part's really important. And so I like to definitely start with that. Since f of x is a polynomial, I can say it's continuous everywhere. So if I can start with that sort of first initial statement, then I've got the continuity thing taken care of. Which means that somehow, and I don't really know what it's doing in between 6 and 7. It could be going up, down, it could be squiggling, or it could just be going straight up. I don't really know. But I know it's got to be continuous, right? So it's somehow continuous in there. Which means I have to prove there is a real number a in 6 to 7 such that f of a equals 100. Oh, so where would 100 be? Well, it'll be somewhere in here, right? And so therefore, there has to be some value a between 6 and 7 such that f of a equals 100. There's got to be somebody in here. 6.5, 6.67, 6.22, 6. Whatever, I don't know. But there has to be some a in that interval. Does that make sense? That's intermediate value here. The way we now state it is what you guys will practice as you're doing the homework. So basically what I'm looking at here is that, right, there has to be some f of a that's going to equal 100, right? Because it's got to be between these two. And this has to be between those two, okay? So after we state that it's continuous everywhere, then our second part of our conclusion would be something like this. You would say, since f of 6 is less than f of 7, right? 69 is less than 138, then there must be an a, they're calling it a in this one, right? In the interval from 6 to 7, such that f of a equals 100. And that's it, right? And again, that wording, it's not going to be necessarily exact, right? But you do have to explain why, right? You've got to kind of go through. Because 69 is less than 138, because 100 is between those, right? Then you can do somehow, right? So somehow work your explanation. If you use a graph, that can kind of help. But you've got to have it has to be continuous, and then the explaining why. And somehow with the explaining why, using that idea that it's between the other values, okay? And I'll kind of show you some variations on these. As you're checking your answers and stuff too, you'll see some other variations on how to write those answers. Getting there? It's what the writing it up, I think, is more the challenging part. So let's do some more examples. All right, let's try example 4. I think this is technically the last notes. After that, it's just practice. So I'll walk through some practice with you. This is a typical one. We use intermediate value theorem for problems like this. To show that this function, again, we've got a cubic, has a 0 in the interval from 0 to 1. Okay, so again, I do think it helps to kind of look at what's happening graphically here. So here's f of 0, right, and f of 1. So what it's saying is there's a 0 here. What does that mean? That means it's got to cross over, whether it goes this way or goes this way. But it's somehow got to cross over my x-axis here, right? I have to have a solution or an x-intercept or a 0 somewhere between 0 and 1, okay? So let's go through those first steps. First step is it continuous? Well, it's a polynomial again, so I just can say again, since f of x is a polynomial, therefore it is continuous everywhere, and I've covered my bases. Okay, now let's do this work again with the f of 0 and f of 1. So since these are my two values, I'm going to plug in f of 0. I'm going to plug in f of 1. This one you can do by hand. When you plug in 0, what do you get? Negative 1. When you plug in a 1, what do you get? What do I get? 2, right? Okay. All right, so think about that graphically. F of 0 is negative 1. That's down here. And f of 1 is 2. You guys see it now? So obviously, I'm somehow going to have to cross over. Again, I don't know how exactly, but it's going to have to cross over my x-axis. So there has to be a 0 in between there. Okay? So for this one, it's pretty easy. What we can state here in sort of our conclusion is I would say since f of 0 is less than 1, just kidding, less than 0, it's negative, and f of 1 is greater than 0, right? This one's a negative, this is a positive, right? So since f of 0 is less than 0 and f of 1 is greater than 0, there must be a 0, you can just call it a 0, in that interval from 0 to 1 such that, oh no, I don't even need it. I'm good. Because I used the word 0 in here, that already took the explanation away. There must be a 0 in that interval, period. Because the first one is negative and the second one's positive, we've got to cross over, and it has to equal 0 somewhere in that interval. Right? There has to be something in here that's going to be exactly equal to 0. Okay? So what I really want to practice is this writing up of it and explaining it. Okay? And that's going to be part of it as we go through this. Right, technically that's it for notes. So why don't we practice together a little bit with our remaining time. Your homework is supposed to be pages 28 and 29. So let's work on it now and see what you can do. These first two are just like the one we did. You're using IVT to verify that it has a 0 in those intervals. So go ahead and start with 1 and 2, and then we can kind of check them together. And I can help you work through these. I'm going to try and upload this video too.